We are going through the tutorial solutions. This is nothing for us. Let's just quickly go through it. And let's see, this is very easy. We've done a lot of work. Let's see. So the first thing they are going to be asking you is about this notation symbol. This notation symbol, let me just talk about it 2 minutes. This is called sigma, okay? We know that there is another sigma like this, which we know means the population standard deviation. If it's sigma squared, it was the population variance. It is to do with population. This is the small letter sigma, okay, for Greek. This is the capital sigma, and this capital sigma, we borrowed it and we use it here to represent summation when you are adding up things. So now whenever you use it, let's say you have terms, you just want to say that mean x bar is going to be, or let's say you are adding up terms, right? Many x terms all the way to some value which you don't know. You can just say that mean is just going to be the summation of x divided by n. So this sigma is just to say the sum. Now, sometimes we go to be using the a notation which tells us more, okay? When we want a notation which tells us more, then what we just simply do is instead of just putting a basic sigma like this, we are going to put some subscripts, and these help us to know. We use them when we know how many things we are adding. Let's say that I know that I'm adding 3x values, x1, x2, and x3. I only have 3x values. Then when I say my mean, I can say this is going to be the summation. Now that I know how many x's, I don't just say sum of x, okay? I will now say sum of x, and I'll put this I to say I'm about to tell you how many they are, and I'll say from 1 up to 3. So I'm adding these x's from x1 up to x3. So where there is ni, this just tells you where you are going to be summing, where you're going to be changing. So whenever I see a term with an I, it's the one that is going to be increasing in number. And we use the numbers that will be here to know which one. If we were adding x4, x5, x6, and x7, I would say still the sum of xi because the 4, 5, 6, 7 is on x, and I would say from 4 up to 7. That's what happens, okay? Then I can say divided by n. So I'm going to sum these and divide by the number of terms. So that's kind of what we do. We use it when we are knowing how many terms that we have. Then we like to use this I, okay? Now let's go through the questions and let's see how we can be doing. So here we can start with part A. And they said, I'm going to write this side because for this one, it's for me to copy all this and put it on the other side. No. This is Z1 plus Z2 plus Z3 plus Z4. What is this? It's just going to be the sum of Z. And since Z is increasing on 1, 2, 3, 4, it's the one we put I. Then it's from 1 up to 5. So we say where I is from 1 all the way up to 5. Okay. So you get it? So it's going to be, let me reduce the crayon size so that we can all can think. So it's going to be the sum of Z. So you say sum of Z from 1 up to 5. This is going to be it. Now here we have x5, x6, x7, x8, x9, x10. This is a 10, not 1, 0, but it's a 10. Then 11, x12. So this, we are starting from 5 and ending at 12. What is it? X value. So it's the sum of x values. We put this I. So we show that it's from 4 to 12, okay? Because it's from 5 to 12. We'll be knowing the things that we are adding. That is when we use that notation. So now we have again x1, f1, x2, f3. So when we have these two things like this, it's x and f. Both of them are increasing from x1, f1, x2. So we can say this is going to be now equal to the summation of xi, fi, because both of them are increasing. And we say from 1 up to 6. Sorry, because it's ending at x6, f6. So we can say from 1, oh my goodness. So we can come here and say that it's from 1 up to 6. So we can say that it's going to be the summation. No space. It's the summation of xi, fi, because both of them are increasing. And we say from 1 up to 6. Now let's see for this one. y1 squared, y2 squared, y3 squared. Where do we have the 1, 2, 3? It's on y squared, okay? It's on y squared. So we can say that this is the summation of y squared, but we put an I. then we say it is from 1 up to 3. Okay, where there is I, that's where we'll be having 1, 2, and 3, right? Oh, good. Now we have here 2x1, 2x2, 2x3. Can you see that 2 is not changing? Yes, it's only the x that is changing. Yes, from what? From 1 up to 7. So we can say that this is going to be equal to the summation of 2 is just there, it's not changing, but x is the one we'll put an I. Then we say from 1 up to 7. All right, so here now we have x2, y2, x3, y3, x4, y. So this is just, again, x and y are both changing. So it's the summation of x, I, y, I. And where did they start? From 2 and end at 4. So from I equal to 2 to 4. That is where they do. Now here we have what on part G? Z2 plus 3, Z3 plus 3, Z4 plus 3, Z up to Z5. We have Z5 plus 3. We can see that the plus 3 is not changing. So it's just going to be the summation of Zi and plus 3. Okay? This I is starting from 1 up to 5. Okay? It was Z1. No, it's starting from 2. 2 up to 5. It's because it's starting at Z2. Then it's Z3. That is what we'll be having, right? Then now we have this one, x1, y1, f1, x2, y1. So 3 things are changing. So it's still fine. This is just going to be the sum of xi, yi, fi. Okay? And we can say it is from 1 up to 4. So we can say where I is from 1 and ending at 4. So from I1 up to 4. Then now we are at the last one. No, we are done. Okay, so we are done with the first part. This is going to be the first part, and I was supposed to separate this so you can see these are the solutions. Okay, sorry for being a little bit scruffy. We'll do the next question, which is number 3. Oh, how weird. There's no number 2. So yes, this is all you needed to do for the first one. We can go to number 3 and we'll see what it is. We'll do it in the next video. Goodbye for now.